Alright, so in this problem, I have x to the power of x is equal to 4 to the power of 1024. So I want to find the value of x here. So for my solution, first start with x to the power of x is equal to 4 to the power of 1024. And now, I'm going to rewrite 1024 here as 4 times 256, because 1024 is 4 times 256. So now I have x to the power of x is equal to 4 to the power of 4 times 256. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 4 to the power of 4 times 256, that's the same thing as 4 to the power of 4 to the power of 256. And now, well, 4 to the power of 4, that's the same thing as 4 times 4 times 4 times 4. Now, we have 4 times 4 times 4 times 4. 4 times 4 is 16, so I have 16 times 16, which is equal to 256. So now I get x to the power of x is equal to 256 to the power of 256. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, a to the power of a, x to the power of x, is equal to b to the power of b, 256 to the power of 256, meaning x is equal to 256. So now to we have x to the power of x is equal to 256 to the power of 256. Sorry. We have 256 to the power of 256 is equal to 4 to the power of 1024. And now 256, again, that's the same thing as 4 to the power of 4. So now I have 4 to the power of 4 to the power of 256 is equal to 4 to the power of 1024. And 4 to the power of 4, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 4 to the power of 4 to the power of 256 is equal to 4 to the power of 4 times 256, which is equal to 4 to the power of 1024. So I get 4 to the power of 1024 is equal to 4 to the power of 1024. Check. Alright, so in this problem, I have 9 to the power of x is equal to 36. So to start, I'm going to start by taking the log on both sides. So now I have log 9 to the power of x is equal to log 36. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 9 to the power of x, and we can think of x as b. So we can move this to the front. And now this is going to equal x times log 9 is equal to log 36. So now what I'm going to do is I'm going to divide both sides by log 9 so we can isolate x. So now I have x times log 9 over log 9 is equal to log 36 over log 9. So then these two log 9s simply cancel out, and I have x is equal to log 36 over log 9. Now, log 36 over here, we can rewrite as log of 9 times 4. And we have this over log 9. So if I have something in the form log of a times b, this is the same thing as log a plus log b. So in this case, I have log 9 times 4, and I can rewrite that as log 9 plus log 4. Now I have this over log 9. So now, this is the same thing as log 9 over log 9 plus log 4 over log 9. Now log 9 and log 9, these two obviously cancel out. So now I get x is equal to 1 plus log 4 over log 9. And log 4 I can rewrite as log of 2 squared. Log 9 I can rewrite as log of 3 squared. So now this is the same thing as 2 times log 2 over 2 times log 3. And the 2's can simply cancel out. So I'm left with x is equal to 1 plus log 2 over log 3. Now log 2 over log 3, that's the same thing as 0.301 over 0.477, which is equal to 0.631. So x is 1.631. Alright, so in this problem, I have 5 to the power of x is equal to 0. So I want to find the value of x here. So for my solution, I first start with 5 to the power of x is equal to 0. And now I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 0. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log 5 to the power of x, we can think of a as 5 and b as x. So I can move x here to the front. So now I'm going to have x times log 5 is equal to log 0. Now, from here, I'm going to simply divide both sides by log 5 because we want to find the value of x, so we're going to have to isolate it. So then these two cancel out. And I am left with x is equal to log 0 over log 5. Now we're actually going to plug in the values of log 0 and log 5. So log 5, this is equal to 0.6990. And log 0, well, what is log 0 equal to? Log 0 is actually undefined. So I have x is equal to undefined over 0.6990, meaning x is simply undefined. And another way to actually prove this is our equation was 5 to the power of x equals 0, right? Well, 5 to the power of 0, this is equal to 1. Let's do 1 less than 0. 5 to the power of negative 1, this is equal to 1 over 5. Let's do one less. 5 to the power of negative 2. This is equal to 1 over 25. 5 to the power of 3. This is equal to 1 over 125. Sorry, 5 to the power of negative 3. And this is going to go lower and lower and lower because, as you see, as the exponent decreases, the number decreases as well. However, it's actually never going to approach 0. So no matter how low the exponent might be, we could even do 5 to the power of negative 1 trillion or something like that, and it's never actually going to be 0.